Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics N4. So in this platform actually we are having the question paper which you guys recently wrote in June 2022 for mathematics N4, which is an X paper. So we shall just quickly rush through the question paper and see how you guys were supposed to answer these typical questions that we had. So with the instructions and information as usual guys that you're supposed to know, especially the degree of accuracy, 3 decimal places, and also to show all working properly and so on. So already this is the paper which you already wrote guys, so we shall just quickly rush through the questions. On question number 1, we are asked to simplify without using a calculator. That is on 1.1 there, which is actually 20 marks. Everything on question number 1, but the first part is just 4 marks. So let's see what we're supposed to, how we're supposed to attempt this typical question here. All right, so this is it guys. Whenever you're working with right, so this is what we had on 1.1. So guys, whenever you're given a trig like this, a trig, remember you have to apply the issue of quadrants. This is what is important, and also to apply all the concepts that you know, the identities and so forth. So in this case we got sine 180 minus x, so we need to know which quadrant are we talking about, which lies 180 minus x. Remember, I've got all students take calculus, and definitely 180 minus x is in the what, in the second quadrant. Remember, this will be your x and this will be your 180 minus x, and this in the second quadrant, and this quadrant is for sine, and that will actually mean this one is going to remain as the sine being a positive of the acute angle, which is the acute angle, which is x. So it is going to give us sine x. All right, then here we have got two options actually. We know that from our cofunction, if we are given tan 90 minus x, this one is going to give us cot x. All right, so if you do not know it, then you are going to write it like this. We know that tan gives us sine over cos, so it's sine 90. Tan 90 minus x is going to be sine 90 degrees minus x, like this. All right, then let me just put it this way. Let me just take this part here, everything over cos 90 degrees minus x. Okay, so you can just actually apply this concept, but you can just quickly, just directly, if you know this relationship, that this one is going to give us cot x. Tan 90 minus x from cofunction is cot x, or you can write it like this, where we know that sine 90 minus x is equivalent to cos x, and cos 90 minus x is equivalent to sine x. So you can actually write it this way, or you can actually write it this way. So I don't know what was best for you, but it's one and the same thing. So this one we are going to multiply to cot x, which is cos over sine. So it's going to be cos x over sine x. So make sure that the working is done properly guys. All right, everything over, we have got cosec 90 minus x. All right, so we know that so you're supposed to just do maybe the working aside. Cosec 90 minus x, we know that cosec is 1 over sine. If it is cosec, so it's 1 over sine, but we have got what, 90 minus x, and previously we said sine 90 minus x is equal to cos x. So this one is going to give us 1 over cos x. All right, so we are going to have 1 over cos x here, multiply by, we have got a cos 360 minus x. Okay, so this one we are going to use the reduction formula. Direct, we know that 360 minus x is in the fourth quadrant, where this is your x and this whole angle here will be 360 degrees minus x. So it's in the fourth quadrant, and this quadrant it's for cos, which means cos is a positive. So we are going to have a positive cos. So it's going to be positive cos x. All right. Then we have got cot 180 plus x. Take note, cot 180 plus x. All right. So actually, cot is cos over sine. We know that cot. So if it is cot 180 degrees like this plus x, since cot it's cos over sine, so it's going to be cos 180 degrees plus x over sine, just like this, 180 degrees plus x, just like that. Okay, but we know that from our quadrants back to this here, 180 plus x is in this quadrant here. That's your 180 plus x. This is your x here, and this is your 180 plus x. So it's in the third quadrant, and in this quadrant it's tan, which is positive, which means cos is a negative. So it's going to be negative cos x. Also, this sine is a negative, so it's going to be negative sine x in terms of the acute angle, but negative and negative is going to give us a positive cos x over sine x. All right, so this is going to give us a positive, I want to put it here. So this is the resultant from cot 180 plus x. This one, it gave us cos x over sine x in simplest form. So this is cos x over sine x. All right. So as we can see, guys, we have managed to simplify in terms of the acute angles and so forth. So actually we can cancel whatever possible. This one is same as over 1, so you can actually cancel this cos, and cos can cancel. As we can see, this is one and the same thing here, so this can cancel cos x over sine x, cos x over sine x, which means here you have left with 1, and on top here you'll be left with sine x. So this one is going to give us sine x over 1. All right, which is equivalent to sine x. Remember, guys, 2 over 1 is just same as 2. 1 over 3, 3 over 1 is same as 3. So sine x over 1 is same as what? Same as sine x. So that's what you just needed there. And you get 3 marks, 4 marks there. Then prove the identity, and you've got 6 marks for that, to just prove this whole identity. Okay, so this is it, guys. We actually know that whenever we are proving identities, we have to pick a side that we are going to work from. So in this case, let me just say I've decided to choose the left hand side, where on the left hand side I am given sec alpha over 1 plus tan alpha, like this. This is what I'm given on the left hand side. So actually this is going to give me, we know that sec is 1 over cos, so I'm going to have something like 1 over cos alpha, like this. Okay, so for me not to like confuse myself, this is a division, this one that we are seeing, so I'm just going to put it this way, as divided by 1 plus tan x, which is 1 plus tan x, which we know that tan is sine over cos, so it's sine alpha, sorry, this is alpha, so it's sine alpha over cos alpha, like that. Because now I'm working with fractions, so it's easier for me to work with these fractions separately, so that I will be able to simplify. So this is just one and same thing, because it's in the denominator, this one, so I'm just going to put it in a bracket so that it can actually make sense. So what is going to happen, definitely, as we can see, there is a need for us to simplify this fraction, combine to obtain a single fraction. We have to obtain a single fraction, so this is just same as 1 over 1. So 1 over 1 in terms of cos actually is same as just cos alpha over cos alpha if you want it. So it's just cos alpha plus sin alpha. Okay, if you don't see it, then find the LCD. What is the LCD of 1 and cos? It's cos alpha. Okay, then we divide cos alpha divide by 1, which is cos alpha, times 1, which is cos alpha, plus cos and cos, that's a 1 times sine, which is sine alpha. Remember guys how you add fractions. Then we are dividing, so you have to introduce multiplication. So it's 1 over cos alpha times cos alpha over cos alpha plus sine alpha. Remember, the moment you introduce multiplication, you invert the second fraction. So definitely this can cancel, which means I'm going to be left with 1 over cos alpha plus sine alpha. This is what I'm going to be left with. But is there anything that I can do further here? There's actually nothing, guys. There's nothing that we can do here. So does this mean that our answer is wrong? Because this is what we have simplified, and it's actually not what is on the right hand side. So what are we going to do? Okay, this is it, guys. This is your left hand side. You obtained this part from your left hand side. Okay, then what you're going to do, if these two are not giving you the same thing, you are going to take the right hand side, work from the right hand side, and see a miracle that is going to happen from there. So this is our right hand side. So let's see a miracle which is going to happen from there. So this is cosec. I wonder why am I writing this side. Let me just write it here. This is cosec alpha here on our right hand side here, over 1 plus cot. So it's over 1 plus cot alpha in this case. So just like what we did here, we are just going to simplify, doing the same thing, separate. So cosec is 1 over sine. So we're going to have 1 over sine alpha divide by, so that we don't confuse ourselves. So it's going to be 1 plus cot, which is cos over sine. So it's cos alpha over sine alpha, like that. So as we can see, guys, we are now back to the normal simplification, just like what we did last time. So it's going to be divided by, we've got our LCD, because this is same as 1 over 1, which is 1 and sine, which is sine alpha. So sine alpha divide by 1, that's sine alpha. Then you multiply to this one, which is going to remain as sine alpha, plus sine alpha divide by sine alpha, that's going to be a 1. Then you multiply by cos alpha, which is cos alpha, like that. Then as usual, you have to get rid of that division. So it's going to be 1 over sine alpha times, the moment you introduce a multiplication, you now invert the second fraction, which is sine alpha over sine alpha plus cos alpha. So this is what is going to happen. So we are going to have 1 over sine alpha plus cos alpha. So this is what we actually obtained from the right hand side here. And this part and the last part, now if we are to compare these two, they are the same. 1 over cos alpha plus sine alpha. This is just like 1 over a plus b, and another fraction is written as 1 over b plus a, like this. This is just one and the same thing. So these two, they are the same. So we are actually saying this part here, which is 1 over cos alpha plus sine alpha, is equal to the part on the right hand side, which is 1 over sine alpha plus cos alpha, what we obtained. So this is our left hand side, which is actually equivalent to the right hand side. So that's what we had, guys. So in some cases, it's not always where you are going to find something that is going to happen direct like other identities, yes, they can happen direct, that you just prove this to this side direct, but some it's a matter of balancing from the two sides, just like that. Unless, guys, this, you see guys, identities, there are so many ways of answering. So if you have got any other way, let me know. Let me know your view is actually accepted, so that I will know maybe there was another condition or another way. Okay, on 1.3, determine the general solution for the following equation. The general solution for the following equation, which is all right, this is our equation here. So what do we have here? How are we going to solve such type of an equation? Okay, this is the issue, guys. If we are to see properly here, there is a square that we are having here. We've got a square there. All right, then before that there is a 4 which is multiplying, and it has nothing to do with this cos, so you can actually remove this 4 by just dividing by it both sides like this. So that means we are going to have cos squared x over 2 plus 40 degrees, which is equivalent to 3 over 4. Take note, this is a squared, and how do we remove this squared? It's simply an introduction of the square root both sides, which we know that square root of any number is going to give us a plus or minus. So the moment we introduce this square root, we are actually getting rid of the square, so which means we are going to be left with cos x plus 2 plus 40 degrees like this, which is equivalent to plus or minus square root of 3 over 4 from your calculator is going to simplify further to square root of 3 over 2. So this is actually what we have. That's what you have there. So which means we are going to have two possible solutions here, a plus and a minus from these two. So which means we are going to have cos x over 2 plus 40 degrees, which is equivalent to square root of 3 over 2, or another condition of cos x over 2 plus 40 degrees, which is equivalent to negative 3 over 2. So we know that actually to remove this cos, we are going to write this side as arc cos, like that, arc cos square root of 3 over 2, which is just shift cos from your calculator, and this is going to give you 30 degrees. And now it's a matter of the quadrant. Which quadrant are we talking about when this is a positive? When cos is a positive, remember from your quadrants, you're talking of all students take calculus, which means you're talking about the first and the fourth quadrants. All right, so this is what you're going to have, x over 2 plus 40 degrees is equivalent. So we said arc cos. To remove this cos, you write it as arc cos like this, which is shift cos from your calculator, and it's going to give us 30 degrees. So which means we are going to have in this first quadrant, which is 30 degrees, and in this quadrant we have another 30 degrees. So but we know that the actual angle here, because this is the reference angle actually of 30 degrees, so in the first quadrant it is going to remain as it is, but in the fourth quadrant our actual angle, which is theta or x, is going to be 360 minus the reference angle, which is 360 minus 30 degrees, which is actually gonna give us 360 minus 30, which is 330 degrees. So which means we've got two solutions when this is a positive. When this cos is a positive here, we are going to have two solutions in the first and in the third quadrant, in the fourth quadrant, I mean. So here we are going to have the first angle, which is 30 degrees, and another one, x over 2 plus 40 degrees, which is equal to another angle, which is 330 degrees. So that's another solution that we can have there. So this is when it is a positive. But we also have a condition again when it is a negative on this side here. So when it is a negative, which means we are referring to the second and the third quadrant. And in the second quadrant, we know how do we calculate this. Actual angle is going to be x is the actual angle which is x. So it's going to be 180 minus the reference angle. So it's 180 minus 30. And we know that 180 minus 30, which is going to give us 150 degrees. All right. So here we are going to have x over 2 plus 40 degrees, which is equal to 150 degrees. Or another one, here in this quadrant, because it's a negative for tan, so it's going to be 180 plus 30, this one. So it's 180 plus the reference angle here. So 180 plus 30, which is 210. So it's going to be x over 2 plus 40 degrees, which is equal to 210. So these are the possible solutions that you can actually have. And here it's just a matter of transposing that this side is going to be minus 10, 30 minus 40, which is minus 10. Then we multiply by 2 because it will be like this. X over 2 is equal to minus 10. Then you cross multiply, which is going to be minus 20. So you're going to have minus 20 degrees here, or x here, which is you subtract first 330 minus 40, whatever that you get, you multiply by 2. So 330 minus 40, which is 290 times 2, which is 540, something like that. So you just solve just like that. Here you subtract again, you multiply by 2, which is going to be 220. Here you do the same, you subtract first, then you multiply by 2, which is going to be something like 140 degrees. So these are actually the possible values of x. But if it is a matter of writing it in a general solution way, then it means we're just supposed to write as x over 2 plus 40 degrees is equal to plus or minus 30 degrees, because when this is a 30 and it's a positive, it is going to be in the first and in the fourth quadrant. So you can just write as plus or minus, okay, plus 360 degrees k, where k is representing all the possible values that we can have. So we can actually have all the solutions from this part. Then you just make x to be the subject. So you see, there will be so many ways of actually attempting these questions and answering the questions. Okay, so find the value of 1 over cos, or cot. It's 1 over cot actually, not cos, without using a calculator. All right, so this is what we have, guys. 1 over cot. We know that 1 over cot, it's going to give us tan, because we know that 1 over tan is cot. So if it is 1 over cot, then it's going to be tan. This is 1.4. So we are saying 1 over cot 75 degrees, like this. Okay, so actually 1 over cot is tan. So this one is going to give us tan. All right, which is tan 75 degrees. So there are actually many ways that you can actually write it or have it, because someone can have it as 1 over sine 1 over like this. Then cot, we know that it's cos over sine, so it's going to be cos 75 over sine 75, like that, which then you interchange, it's going to be sine over cos, which is the same as tan. All right, so as you can see, it's just one and the same thing. Now we have to separate this angle of 75 degrees depending with what we have on our formula sheet. So now, in order for us to separate so that we can apply these special angles, we have got these angles of 45 degrees, 30 degrees, 60 degrees. These are the special angles that we have. And we just need to make sure that if we are to combine two angles here, they can actually give us 75, just like 45 and what? And 30. If we are to combine these two angles, they are going to give us 75. All right. But now we need to expand, because we are going to have two angles. So we have to write in terms of something that is clear to us, which is sine 75 over cos 75. Actually, I was just supposed to write this as 45 plus 30 here. then it was going to be sine 45 plus 30 cos 35 plus 30, like that. But still, it's one and the same thing. We said 45 and 30 are the two angles that we are going to add to give us 75 here. So it's going to be sine 45 plus 30, like this, into cos 45 plus 30, like that. All right. So actually here we can apply our ratios, our identities, because this is A and B, and we know that sine is going to give us sine cos. So it's going to be sine A cos B, which is sine 45 cos 30. So we've got sine 45 cos 30, like this, plus. So remember, sine does not change, but it's going, this sign does not change, but it's going to be cos 45 now, sine 30. So it will be cos 45 sine 30 degrees. All right, everything over. We know, guys, cos is going to give us cos minus sine. So it's going to be cos 45 degrees cos 30 degrees minus sine, which is sine 45 degrees sine 30 degrees, just like that. Okay, so sometimes, guys, it's just a matter of working out whatever that you're given, simplify further, substitution of from your special triangles, because we're given not to use a calculator. So definitely have to apply our special angles, which we know of 45 degrees and so forth and so forth and so forth. So we've got 1 square root of 2, and this another one, which will be having 60 here and 30, just any way that you want to write it in a proper way, and this will be square root of 3. All right, so sine 45 to be opposite over hypotenuse, depending with which 45 are you talking about. If this is this one or this one, still it's the same answer, opposite over hypotenuse, which is 1 over square root of 2. So we are going to have 1 over square root of 2 times cos 30, which is adjacent over hypotenuse, square root of 3 over 2. So it's going to be square root of 3 over 2 plus cos 45. Remember, cos 45 and sine 45 are the same, which is 1 over square root of 2 times sine 30. Sine 30, that is opposite according to 30 over hypotenuse. Remember from your soccer tour, guys, if you actually forget this. So sine opposite of hypotenuse, which is 1 over 2. So we're going to have 1 over 2 like this. Everything over cos 45, we obtained it here. It was 1 over square root of 2 times cos 30. We obtained it here, which was square root of 3 over 2 minus sine 45. We obtained it here, which was 1 over square root of 2 times sine 30. We obtained it here, which was 1 over 2. So as you can see, it's just a repetition, a normal repetition, guys. All right, so actually here we could have we could simplify here, because if you are to cross check here, you are going to see that here these two can multiply, and you can actually simplify as much as you can here. Okay, because this is just same as 1 times square root of 3, which is actually like square root of 3, like this. This is what it means actually. Maybe let me put this in. This one and this one is just like square root of 3 and 2, and square root of 2 is going to be like 2 square root of 2, like this. So it depends with how you want to write it. And the same here, 1 and 1, 2 and 2 square root of 2. So it's 1 over 2 square root of 2 over, this one is going to be 1 times square root of 3 this time, which is actually square root of 3 over 2 square root of 2 minus, this one is just 1 and 2 square root of 2, 1 2 square root of 2. All right, so we can actually simplify the numerator here, combine it, and combine also the denominators separately, which means here we are just adding, because the denominators are the same. Remember, when these two are the same, you just combine the numerators. So it's going to be square root of 3 plus 1 over 2 square root of 2. You just combine because these are the same, the denominators, okay? And divide to the denominator here, which you do the same because the denominators are the same. So you just subtract the numerator, square root of 3 minus 1. So it's going to be square root of 3 minus 1 over 2 square root of 2. All right, so remember, you are dividing. You have to introduce multiplication, which is going to give us square root of 3 plus 1 over 2 square root of 2 times. The moment we multiply, we are inverting the second fraction, which is square root of 3 minus 1. So these two can cancel, which means we are left with square root of 3 plus 1 over square root of 3 minus 1. So yes, you can actually rationalize there, but guys, because of 4 marks, we'll just leave it that way because these marks, guys, 4 marks, I think it's fine there. All right, so that's what we had. And on question 2, show that log y base 1 over 2 is equal to negative log y in base a, hence determine the value of x if you're now given a question to solve from that part that you asked to first show. So guys, this is what I actually think of here, that's gonna be best for us. Remember, there are so many ways to prove. Okay, I took the second part. I want to start with the first part first, which is just to prove, which is log y in base 1 over a is equal to minus log y in base a. Okay, so this is what we want to just prove first. So I'm going to take the left hand side in this case and see what is worthy from there here. All right, we know that here, guys, there's nothing that we can actually do here. We're just given a single log, but we know that from the change of base we can write this as log y over log 1 over a, like this, when we are to write in terms of another base, or writing in terms of just normal logarithm. It's just one and the same thing. But the moment we write this now as a log, it now gives us the power now to write it as log a to the exponent of minus 1 from 1 over a, which is a to the exponent of minus 1. So the moment we are able to write this as log y over log a to the exponent of negative 1, it means we can now apply the laws of logarithms, where we can drop this exponent and it's going to be log y like this over negative log a. And the moment this is a negative, remember, negative, you can write it on top like that. So it's going to be negative log y like this over log a like this. But remember, guys, what we did here, we said writing log y over log 1 over a like this is the same as log y over, same as log y in base 1 over a like this. So it means writing log y like this in base, in over log a is same as writing log y in base of a, just like this part here. Okay, y over this part is the one that gave us this. So this part here can be written in short as minus log y in base of a. So it's log y in base of a from this law that we applied first. Now it's a reverse. We are coming from this now back to this law. So that is what we are going to have. And this is actually equivalent to the right hand side, which is the condition that we are given on the right hand side. So it's actually a concept that they just want you to use or to apply. Now if you can know it, then you can actually apply this concept. It wasn't a much bigger deal there, because there they even asked a question where they wanted you to apply that concept now, when they are now saying solve for x, where they know that you can't even solve for x here. Why? Because the bases are not the same. So what you're going to do is to rewrite this now in terms of this part here, because remember we said when it is log y in base of 1 over a like this is going to be minus log 1 in base a. So it's minus here. So this one, because it has got 1 over 3, this 1 over a, so it's going to be minus log of this part which was already there, which is 5 minus 2x like this in base of the whole number, which is 3. So yes, it seems like we haven't done anything by just rewriting to this, but we have done a greater thing, because now we are given the same basis, which is base 3 and base 3, which means we can actually temper or play around the question. So how can we play around the question? Okay, this is it, guys. We can take this log to the other side of the equation, which is going to be log 3 minus x in base 3, minus to this side is going to be plus log 5 minus 2x like this in base 3, which is going to give us a 0 here because we have taken this to the other side. So take note, why are we taking this to the other side? Because we can apply the laws of logarithm, because remember that from our laws of logarithm, when the bases are the same and you are adding logarithms, you are going to multiply the numbers. So it is going to be log 3 minus x like this times this number or this bracket in base of 3, which is going to give us a 0 like that. So at this stage someone is asking, so how am I going to solve for x? What am I going to do from this whole part? Okay guys, we know that from our laws of exponent from your n2, guys, I talked about this here, which is equal to c, that in this is log form, so in exponential form a is equivalent to b to the exponent of c, so you can solve easier in exponent form. So our a in this case is this whole part of the bracket, this part here, which is 3 minus x into 5 minus 2x like this. This is our a, which is equal to b to the exponent of c, and our b is the base and c is the answer, which is here, which is 0. So it's equal to 3 to the exponent of 0, which is actually 1. So as we can see, we have formulated an equation that we can use to solve for x. How? 3 to the exponent of 0 is 1. So this one is just a matter of expanding brackets here. 3 times 5, which is 15. 3 times minus 2, which is minus 6x. Minus x times 5, which is minus 5x. Minus x times minus 2, which is going to be plus 2x squared. Yeah, that's going to be plus 2x squared. And this one we said it's a 1. 3 to the exponent of 0 gives us a 1. So you can transpose that 1 to this side. So it's going to be minus 1 is equal to 0, because we have a quadratic equation. So one of the sides must be equal to 0 then. All right. So that means we are going to be left with 2x squared. Okay. Collect like terms, minus 6 minus 5, which is minus 11x. 15 minus 1, which is plus 14, is equal to 0 like that. So this is the stage where we are, guys, and at this stage we are supposed to solve for x. So you can use your quadratic formula, you can use factorization, depending with which method you are capable to use. So if you use factorization method, you're going to factorize, multiply the first term and the last term, which is actually going to give us 2 times 14, which is 18x squared, and the two numbers that we are going to multiply to get 18, positive 18, and when we subtract, we are going to get minus 11. That's actually for minus 4 and minus 7. Is that so, guys? This is 28, not 28, 28, as this is doesn't make sense now. All right, so it's minus 4 and minus 7. Yeah, now it can make sense, because minus 4 plus minus 7, it's minus 11. If we add this, it's minus 11, but if we multiply, it's positive 28. Here, guys, 2 times 14. 2 is 28, not 18, 28. Sorry for that. So we are going to substitute this, but with x here, into the middle term. So like I said, if you are used to factorization, guys, use factorization. If you are used to quadratic formula, then apply the quadratic formula. Okay, so you're going to have 2x squared minus 4x minus 7x plus 14, which is equal to 0 there. Then we group into 2, which is common, 2x. So it's 2x squared divided by 2x, which is x, minus 4x divided by x, which is 2. Then here we are going to factor out minus 7 so that it can be common. So these two brackets are the same. Now x minus 2, we are now going to factor it out, and we are going to be left with 2x minus 7, which is equal to 0, like that. So take note, guys, that this bracket is common, so you just take it out as it is. Then you solve, so which means x is going to be 2, or x is going to be if we transpose this, is going to be 2x is equivalent to 7. Then you divide by 2 by 2, which is 7 over 2. All right, so this is what you're going to do. You try to substitute these values and see if it is going to actually give you something. But if you have to substitute 2, it is going to work. But this one is not going to work, because here, guys, just take a closer look here. 3 minus 7 over 2. 3 minus 7 over 2 is actually minus 0.5 or minus half. And we can't have log of a negative number, like log minus half like this in base 3. Log minus, this one does not exist. It's an error. So there is nothing that is going to come out from this one. So therefore our x is going to be a 2. So as we can see, guys, that it's an application. It's an application that you have to work on, so that you can actually attempt these typical questions. So 2.2, given that p is equivalent to that, make y to be the subject of the formula. So that's what we had. Sorry, guys, I don't know what happened there. Very sorry for that. So anyways, this is what you're going to have here. We want to make y to be the subject there. So what am I going to do? Okay, I can just maybe divide by k, because this k is nothing to do with this part, so I'm going to divide by it, so that I'm going to be left with p over k equivalent to 1 minus 10 to the exponent of x over y, like that. All right, I want to make y to be the subject, but as I can see, this is surrounded by a negative base. So let me try to make it a positive, transpose it to this side so that it can be a positive. So you're going to have 10 to the exponent of minus x over y, which is equivalent to 1. Then transpose p minus q to this side, which is going to be p over k, minus, because it was a positive, this one, so it's going to be a negative. All right, so this y that we want is on the exponent, so you can actually introduce our ln, which is going to be minus x over y. Ln 10 is equivalent to ln 1 minus p over k. So ln is going to affect everything. Then here, remember, the moment you introduce ln, you drop the exponent, like that. All right, so I want to make y to be the subject, but this y is in the denominator here, so I'm going to multiply by this y both sides so that it can be in the numerator there. So remove this y here. I'm going to be left with minus x ln 10, which is equivalent to, because this is cancelled, so I'm going to be left with minus x ln 10, which is equivalent to y times ln this, so it's going to be y ln 1 minus p over k, just like that. This y is no power to multiply inside the bracket, no, it's just y there. There's no power to multiply. All right, so now we can actually make y to be the subject. Why? Because I just need to divide by this ln 1 minus p over k, both sides, so that at least it can balance. So remember, it's an equation. Whatever you do on the left hand side, it has to be done also on the right hand side. So what we did on the right hand side has to be done on the left hand side. So therefore y is going to be equivalent to negative x ln 10 over ln 1 minus p over k, just like that. So that's what we had, guys, and I think it was straightforward. Anyways, all right, on 2.31, sketch the graph of this straight line. All right, so y is equivalent to minus 2x over 3 minus 1. So guys, a straight line does not even change. For you to sketch a straight line, it's always one and the same thing. You need the x-intercept, you need x-intercept and the y-intercept. So the x-intercept is on a condition that y is equivalent to 0. We know that for the x-intercept. So if y is equal to 0, you're going to have minus 2x over 3, which is equivalent, which is minus 1 there. So we can find x, just transpose this, is going to be negative 1 to this side is 1, which is equivalent to negative 2 over 3x. Then divide by this part here, negative 2 over 3 both sides. So x is going to give us negative 3 over 2. So if we divide by negative 2 over 3 both sides, divide here, divide here. So this is your x-intercept. Okay. Then we need the y-intercept, which we know that x will be equal to 0 there. So by just putting here x is equal to 0, as you can see, y is going to be negative 1. So we can actually sketch our graph here. So what you just need is to do it in a proper way, guys. Okay. So according to the values of x is negative 3 over 2, which is negative 1,5 actually, which can be maybe somewhere here. That's our x. And our y is a negative 1, which is y. Here is negative 1, which may be somewhere here. Then you just join properly using your ruler, even though sketch, but you have to use a ruler there. So that's what we had, guys. That was the graph. It was just a straight line. Make sure the x-axis is there, the y-axis is 0, 0, the intercepts, then and so forth. So is this graph going to be continuous or discontinuous? This is a continuous function that we have there, and that's a continuous function. Actually 2.33 now is asking, is it a function or a relation? So if it is continuous, then it means it's a linear function. So this one follows under a function. Then is it asymmetrical or symmetrical about the x-axis? So as you can see, guys, this one is not asymmetrical. It is not asymmetrical. It's symmetrical. So it's going to be asymmetrical on this one. All right. Then that's what we had. Then draw the graph of. So that's what we had. Then here is the draw the graph of x is equivalent to. So let's just see. It's 2.41. which is x is equivalent to minus 4y squared. So this one is a negative graph, which is, and also it's opposite actually to y is equal to x squared. So it's going to be like this, guys. Sometimes you have to just know how these graphs will look like. So it will be like this, yeah. If it is a positive, then if it is a positive, it's going to be like this. Okay, this one is a negative, so it's going to be either way. It's going to be the other way, like that, and this will be y-axis and our x-axis or 0 there. So this is going to pass it 0,5 and minus 0,5. So that's what we had, and is the graph this symmetrical about the x-axis or y-axis? So this is about the x-axis, about the x-axis. Okay, then draw the graph of so on any other part that, guys, that is not clear, let us just know on the comment section. So let's just know. So x is equivalent to 9 minus y squared, square root of 9 minus y squared. So this is actually a circle, guys. If you are cross-checked properly, the moment you square both sides like this, is going to be x squared is equal to the square. You're actually removing the square root, so it's going to be 9 minus y squared, like that. So the moment you transpose this to this side, is going to be x squared plus y squared is equal to 9. All right. Then from this part, this is going to be, remember, this is a circle center 0, 0 here, where the radius is square root of 9, which is 3. So you're going to have a radius of 3. So actually, that's a circle that we have there. sec 0, and that's radius 3, so this is going to be minus 3, minus 3 and 3, so that's your y-axis and your x-axis. So that's it. Or you can apply the x-intercept and y-intercept when x is equal to 0. When y is equal to 0, we have y, which is plus or minus 3, x, which is plus or minus 3. Still, you have the same answer, guys. Or just to know that what am I having there and what is gonna be the range. So the range, remember, range affects the values of y. So as you can see, the values of y are limited from minus 3 up to 3. So that's gonna be 2.52, which is y is greater or equal to negative 3, lesser or equal to 3. And this y actually is an element of what? Of the real numbers that we're going to have. All right, then on question 3, integrate whatever that we had there. I actually wrote this down here. So how can we integrate, guys, here? So you can actually multiply first. If you maybe have challenges with integrating then multiplying by 4 later on, you can then multiply by 4 first. It's just one and the same thing. So it's going to be 4 theta to the exponent of 5 minus 4 theta to the exponent of 3 plus 4 times 3, which is 12 theta, like that. Okay, the theta. So now we are going to integrate with respect to theta. So remember, when you integrate, guys, you add exponents. So we add 1, so it's going to be theta to the exponent of 6 over 6 minus, we add 1 here, which is minus 4 theta to the exponent of 4 over 4. All right, plus 12 theta to the exponent of 2. If we add 1, it's going to be 2 over 2 plus the constant of integration. But we can't leave our answer like this, because we can actually reduce 2 over 3 theta to the exponent of 6. This one and this one can cancel. All right, 12 divided by 2, which is actually 6 theta squared plus z. So this one is just now a matter of writing in simplest form, but already the answer was there. So that's integration for you. Integration, guys, just add exponent. Then that one was also to integrate, and we are given the limits there. So remember, guys, I talked about the integration where you'll be given limits that you have to integrate and substitute with the limits. But how can we integrate that? Definitely I have to separate this, divide each and every term by p, because this is same as p squared over p, plus we separate here 2p over p. Okay, one and the same thing, minus 1 over p. We separate each and every term. So this is going to be p squared divided by p, which is p. So you're going to have the integral with limits e 1 over e. So this is going to be p plus, okay, p and p will cancel, you remain with 2, so it's going to be plus 2. Then this one is going to be just minus 1 over p. So that's what we can do, so that we can integrate. Otherwise there is no other way that we can do it. Okay, so at this stage now we can integrate, guys. It's a normal integration that we are used to integrate. P with respect to p is going to be p squared over 2 plus, if we integrate a constant with respect to p, it's going to be 2p. Then the integral 1 over x here is going to give us ln x. So it means if we are given minus 1 over p, is going to be negative ln p. All right, so that's what we have, guys, and we are given the limits, so there's no need for us to write the plus c here. If you're given the limits, so we just need to substitute ln. So this e is there on your calculator, from the Neperian on your calculator there. So it means you have to substitute in terms of p, and also take note, guys, 1 over e is same as e to the exponent of what? Of negative 1, so that at least it can be easier for us. And this one, e is just same as e to the exponent of 1. When you use it from your calculator, you put an exponent of 1. All right, so if this is the case, therefore in place of p we are going to put e, so it's e to the exponent of 2 over 2 plus, in place of p you put e to the exponent of 1 minus ln, in place of p we put e to the exponent of 1. But we know that ln is 1, guys, so you can just leave it like that, minus we now substitute in place of p with this one, which we said is same as e to the exponent of -1. So it will be -1, but there's an exponent of 2, so it's going to be to the exponent of -2. Remember, you multiply exponent and exponent. Okay, 2p plus 2e to the exponent of -1. In place of p, we put e to the exponent of -1. All right, minus ln e p, which is to the exponent of -1, like this. It is going to be easier for you now to substitute from your calculator. So make sure that you substitute this on your calculator properly, and you are going to obtain from this piece alone, it's going to be 8,131, something like that. Then from this part is going to be 1,803, which you subtract is going to give you something like 6,328. Yeah, something like that. So that is the integral. So you just, maybe you can just even put it on your calculator at once, then you can simplify. So as you can see, guys, that's integration for you. Integration doesn't need you to know a lot of things. You need to know the basics of integration. That's what you need. All right, so sketch the graph of y is equal to x to the exponent of 3. Indicate the area between y is equal to x to the exponent of 3, the x-axis, lines x is equal to -1 and 2. So this was going to be the shape, guys. Y is equal to x to the exponent of 3. Take note also, you need to know the typical type of a graph and also the shape. So this type of a graph is like this, guys. It's going to be like this. So it passes through the origin at once. That's like that. That's a typical graph that I can use here, where this is 0 here. So this is y is equal to x to the exponent of 3. But actually we are given where to operate from between this graph and the x-axis, between the line x is equal to -1 and x is equal to 2. So -1 is here, so you can just draw this line as our x is equal to -1, so which means we're talking about this region. And also x is equal to what? 2. So x is equal to 2, it's somewhere here. Let's just say it's here. So this is another region again. So we're going to have a representative strip in the x-axis, just like that. So this is the area that we are talking about, guys. But there is something so weird about this area that I want you to understand. Because on the 3.32 now, they are saying calculate the magnitude of the area indicated with the aid of integration, and that's going to be that. Okay, here this area is bounded, but from the same graph there is a piece on this part here which is under the x-axis and a piece which is above the x-axis. So what is going to happen is that you calculate this area here. Let's just say this is on the positive, this is our area A. On the negative, this is our area B. I mean this area inside here, this is a B. From -1 up to 0 here, these are the limits for B. From 0 up to 2, these are the limits for area A, which is on the positive. So this area is going to be a positive area, and this one is going to be a negative area because it's in the negative region. So therefore our area here, remember that our area, guys, is the integral of y with respect to what? With respect to x. Yes, that's the area. But sometimes you must adjust on this formula that you're given. And what are the adjustments that you're doing here? These are the adjustments. We are going to calculate the area for the region of A from 0 to 2. So we are going to subtract A minus the area for B, which is a negative here, so that it can be a positive. So it's going to be A minus B, of which the integral of A is simply the area, because we are saying the integral of y here, which is x cubed. So it's going to be x cubed dx. The limit now for A, our A here is limited from 0 to 2. Take note, guys. This is your A, which is limited from 0 to 2. So we are going to have 0 here, 2, 2, minus the area for B, which is from the same graph of x to the exponent of 3, but this one is limited in the negative region between -1 and 0. Between -1 and 0. These are the limits that you're going to use. All right. Between -1 and 0, like that. So that's a combined function now. We have combined the whole function so we can apply our integration, with which we know that it's going to be x to the exponent of 4 over 4 with the limits 2 and 0 here, minus whatever that you're going to get here also, which is x to the exponent of 4, which is 0 and -1. So that means we are going to calculate the area for A minus the area for B. So the area for A, we substitute 2 to the exponent of 4, that's our maximum value, minus the minimum value here, which is a 0, 0 to the exponent of 4, guys, that's a 0. So this is the area here for A. So this is our A here, minus the area for B. Our maximum value is 0, so it's going to be 0 here. There's nothing that's going to change, so it's just a 0 minus, in place of this is -1 to the exponent of 4, which is a positive, so it's -1 over 4. Or you can just substitute -1 to the exponent of 4 over 4, like that. Okay, so this is what you're going to obtain here. If you simplify, the area for region A is going to give us, if I'm not mistaken, the area for region A is going to be 4. Is that so? 16 divided by 4, which is 4. That's 4 minus, which is 4. Okay, so it's going to be 4 here, minus 0 minus 1 over 4, which is -1 over 4. So as you can see, A is positive, B is negative, but you have to combine them to add them. All right, so minus and minus, that's a plus, which is going to be 4 1/4, or just 4,25, guys, square units. So this is your area, and remember that area is measured in square units. So that's what we actually needed there, just area, guys. So it was a combined type of a question where you have to combine the areas of the two regions, because they are not in the same segment, they are in different segments. So that's how you attempt such typical questions. Anyways, that's what we had, guys. Okay, on 3.4, integrate, this is 1 over sine squared alpha, 2 over cos squared alpha, and so forth and so forth. But we know that, guys, 1 over sine, it's cosec, so which means this one, it means we have got the integral of cosec squared alpha, plus 2, we know that 1 over cos, it's sec, so it's going to give us sec squared alpha, minus 3 over alpha. All right, so this is what you're going to have, guys, the alpha, like that. And remember, the integral of cosec squared, actually you are not given, but I told you guys that the integral is just a reverse. So the integral of cosec squared is going to reverse into negative cot. So this one is going to be equal to negative cot x. The integral of sec squared is the same again. Sec squared, the opposite is going to be tan. Remember, integration is the reverse of what? Reverse of derivative. Tan gave us sec squared. So if we integrate sec squared, we obtain tan x. Okay, so this is going to be plus 2 tan x. Okay, minus 3 over alpha. This one is the one that is a over x, which is a ln x. So it's going to be minus 3 ln alpha, not x. Guys, I'm using x. Where am I getting x? This is alpha, not x. Okay, plus the constant of what? Plus the constant of integration. Remember, guys, whenever you're working with this, you must have the constant of integration there. So that's what we had, and I think it's clear. So let's see another question that we had. Where is this question paper now? This was actually on question 4, and this, as you can see, there is 20, 20, 20. Each and every part is now having its own part, and it's 20 marks and something else, guys. Expand to 4 terms and leave your answer in positive exponents. That's what we had there. And remember, guys, whenever you are working with binomial theorem, we have to know the theorem, how to use it. I think I explained from previous questions how you actually apply the binomial. Remember the binomial, guys, the binomial theorem that is you apply the same way as you do on derivatives. Okay, the issue of dropping the exponent, subtracting one, and so forth, just like what you do on derivatives there. But it's not like you are doing derivatives. I'm just saying you apply the same concept, not like you are doing derivatives. No. Okay, so this is it. You are going to take this x, the first term, to the exponent of -3/4, like this. Okay, then the first part you just take as it is. Okay, then we add now plus. The moment we move on, that's now when we drop the exponent, then we subtract 1. -3/4, then we subtract 1 on the exponent, so it's -3/4 minus 1, which is -7/4. Actually, it's -7/4. Then remember, this -2 starts to appear now over 1 factorial, of which the first part is we can just leave it like that. That 1 factorial has no effect. Okay, we move on. The third term, you drop the exponent again, but now there's already -3/4, so it's going to be plus -3/4, like this. You drop this exponent now, which is -7/4, so it's -7/4. Now we are going to subtract 1. The moment you drop this exponent, you subtract 1, so it's x to the exponent of -7/4 -1, which is -11. Yeah, -11/4. Then -2 increases, so it's -2 now to the exponent of 2/2 factorial. So this was to the exponent of 1. That's why we have 1 factorial. Okay, so we've got 1, 2, 3 terms now, but we are given up to 4 terms. So we need another last term, which is plus. We drop the exponent again, but look how many exponents are there. -3/4 times -7/4 times, we drop this exponent, -11/4, like that. Then the moment we drop this exponent, we are subtracting 1 on the exponent, which is going to be 15/4. Yeah, -15/4. And this -2 is now to the exponent of 3. Remember, it's increasing. 1, 2, 3. It was 0 because it was not there, so it's 0, 1, 2, 3, and so forth, over 3 factorial, plus, and so on and so on and so on. So these are now up to 4 terms. So let's first simplify before we talk of positive exponents. Let's just simplify and see what you're going to have there. All right, so the first part is going to remain as it is. There's nothing that I can do for now. X to the exponent of -3/4. So here is what you're going to do when you're simplifying. You are going to multiply this number here. All right, I want you to listen carefully, guys, so that you don't miss me. You multiply this number here, -3/4 times -2. These are the two numbers that you multiply. Whatever answer that you get, you divide by 1 factorial, which is just 1. So the answer is going to be 3/2. So which means you write it as 3/2, but there's x there, so it's 3x to the exponent of -7/4/2. Okay, you do the same thing. You multiply these numbers here. You multiply this and this, and -2 to the exponent of this part here. These are the numbers that you multiply. So multiply this and this and this together, you get an answer. That answer, divide it by 2 factorial. The moment you divide by 2 factorial, you are going to obtain 21/8. So it's going to be 21 x to the exponent of minus 11 over 4 because it's already there over 8. You do the same, guys. You multiply this minus 3 over 4 times minus 7 over 4 times minus 11 over 4 times minus 2 to the exponent of 3, just like this in bracket. You get an answer. That answer, you divide it by 3 factorial, which is going to give us something like 77 over 16. So it's 77 over 16, but there is x to the exponent of minus 15 over 4. But this is 77 over 16. All right, so that's what we are going to get. Then from there, guys, we are going to write as positive exponents. Remember, how do you remove negative? It's just 1 over, so it's 1 over x to the exponent of 3 over 4 plus, already there's 2 here in the denominator, so it's going to be 3 over 2x to the exponent of 7 over 4. Already there is 8 in the denominator, so it's going to be plus 21 over 8x to the exponent of 11 over 4. Already there is 16 in the denominator, so it's going to be 77 over 16 x to the exponent of 15 over 4. So that's what we had, guys, up to 4 terms. And also in terms of positive exponents, yes, you can write this in another way. Like I always say, guys, if you check most ways that some books, they leave in simplest form, so it depends with the type of source that you are using. That's the idea there. Okay, question 4.2, we are now given a condition where we are determine the limit there. So the actual thing is that here, guys, I want you to see, where did I write this? Okay, it's here. Let's see here. I want you to see something here. Okay, this is what is happening here. We know that this is a sine to the exponent of 3 theta minus 8. We can write this as 8 is same as 2 to the exponent of 3, like 2 to the exponent of 3, like this. Actually, why are we doing this? Why do we have to do this? Because we know that a to the exponent of 3 minus b to the exponent of 3, if we are to factorize this, it gives us a minus b into a squared plus ab plus b squared. This identity, you are supposed to know this identity. All right, where this is our a here, because this one is same as writing as sine, like this, theta to the exponent of 3, like this, minus 2 to the x. So this is your a, this is your b, so that you can clearly see what is happening. So if this is my a and this is my b, therefore I am going to have a minus b, which is a minus b, which is sine theta minus b, which is 2, into a squared, which is a, which is sine squared theta, or you can just write the same way, like sine squared theta, like that, plus ab, which is sine theta times 2, so it's going to be plus 2 sine theta, plus b squared, our b is 2, which is going to be 2 squared, that's a 4. Okay, that's a 4. So as we can see, guys, we can factorize by knowing identities. Knowing identities, they can help us a lot. All right, anyways, this is what you're supposed to get. And it's gonna be limit as x is gonna approach to pi over 2. So as we saw that we obtained sine theta minus 2 into sine theta squared. So you can write it like this, or you can write it like this. Sine squared theta is one and the same thing. All right, so I'm gonna write it like so, since we are going to substitute, so that it's going to be easier for us. Okay, so we obtained 2 sine theta plus 4. So this is actually what you obtained, everything over the denominator, which we are already given, which is sine theta minus 2. So as you can see, after factorizing, some of the miracles, they just happen. You see, they just happen. So you cancel there, then you are left with the limit that you're supposed to apply. So the moment you apply this limit, it means in place of pi, in place of theta, I'm going to use pi over 2, then I square plus 2 sine pi over 2 plus 4. So that's what we mean from this part. And make sure that your calculator is supposed to be in radians now. You are working with pi and so forth. So this, your calculator must be in radians. So this is going to be 1, and this is going to be 2, and this is going to be 4. So if we add everything, that's 7. Is that so? 6 plus 1, which is a 7. 6 plus 1, that's a 7. All right. So that's it, guys. Then if you were to cross check, actually this is under derivatives, limits, you see. So that's binomial theorem and so forth. Now this is actually a derivative thing. And also this type of a question that they can actually ask, where they can ask you to sketch the graph of y is equivalent. That and indicate the x-intercepts, distinguish between the minimum and maximum turning points using the second derivatives, as well as the point of inflection. So there, guys, we had a lot of things to work on. Anyways, let's see. Okay, so I want to sketch this graph. Okay, first we know the shape of the graph when it is a cubic function and it's a negative, how it is supposed to look like. Okay, but before we talk about the shape, maybe we have to talk about intercepts, x-intercept, the y-intercept, and so forth. Maybe it can actually help us. All right, so okay, x-intercepts, which we know that it's a condition where y is equal to 0. So when y is equal to 0, we are going to have minus x squared plus 6x squared minus 9x is equal to 0, like that. So it's now a normal quadratic equation that you just need to solve. So how can we solve this? We can actually divide by -1 throughout. -1, which is going to be x squared minus 6x squared plus 9x is equal to 0. So how can we solve this, guys? This is cubed, not squared, cubed. So we can't just solve this. We have to factor out x because x is common. So it's x cubed divided by x, which is x squared, minus 6x divided by x, minus 6x squared divided by x, which is minus 6x. 9x divided by x, which is plus 9, is equal to 0. So x, then we can actually factorize this, which is going to be, just open two brackets here. I've got x and x, since the coefficient of x squared is a 1 here. So what are the numbers that you're going to multiply to give us 9? But when you add, it's going to give us minus 3, minus 6. So it's minus 3 and minus 3. So we've got minus 3, minus 3 here. So that means x is equal to 0 or x is equal to 3. But this here, the 3, shows something here because it's supposed to be x is equal to 3 or x is equal to 3. So this shows us that this is a solution and it's also a turning point. We shall talk about that one later on, but these are the x-intercepts at x is equal to 0 and x is equal to 3, and at that point y is equal to 0. So we just have 0 0 and 3 0, just like that. Okay, so let's just leave it at this moment, then we move on. So the y-intercept, if you are to cross check for the y-intercept here, it's nothing that's gonna, because x, when x is at 0 here, y is also 0 because there's 0 0 0. So these are y-intercept 0 0. So it means this is both x-intercept, both y-intercept again. So we shall talk about that one later on. What does that mean and so forth? Okay, what are the things that we need whenever we are sketching a graph? We need the turning points. Okay, and we know that the turning points, they come from the derivative, where we know that y x should be equal to 0. And from our y is equal to this part here that we are given, which is minus x exponent of 3 plus 6x squared minus 9x, what is going to be our dy dx? So this is going to be minus 3x squared, 6 times 2, which is 12x minus 9. This is going to be minus 9. And we are saying at the turning point, dy dx should be equal to 0. So minus 3x squared plus 12x minus 9 should be equal to 0. Then you can divide by -3 so that you can solve in an easier way. That's x squared minus 4x minus and minus, which is plus 3, is equal to 0 there. So you can actually use your factorization or quadratic formula in whatever method that you want. So it's going to be x here. We need factors of 3 that you're going to add to get minus 4. That's minus 1 and minus 3. Okay, so x is equal to 1 or x is equal to 3. All right, so that's our x1, our x2. All right, so that we can differentiate our turning point. So which means the first turning point is on a condition where x is equal to 1. Then we shall find the value of y. And the second turning point is on a condition where x is equal to 3, and we shall find the value of y. But this one is not something that we are supposed to be like surprised, because we talked about this before, that this point here at x is equal to 3 is a solution and it's also a turning point. And as you can see, it's repeating this point, and when it was 3, we obtained 3 versus what? 3 versus 0 there. So we are left with this one. When x is equal to 1, you substitute back into this normal equation when x is equal to 1. So y is going to be minus 1 like this in a bracket. This minus will be outside of the bracket like this, plus 6 into 1 squared minus 9 into 1. So you're going to obtain negative 4. So this is our turning point. So we've got this turning point and this turning point. But we are told that we are supposed to distinguish these using the second derivatives. So how are we supposed to distinguish using second derivatives? So remember, we now have our divide x, which is where is this divide x, guys? Is it where we did it here? No, this one was about turning point. It's here. All right, this is our divide x here, guys. So I'm just going to make a continuation from here, which is minus 3x squared plus 12x minus 9. So the second derivative, we know that for you to, so this one is now to distinguish. So we want to determine the nature of turning points. Is it maximum or minimum? So we know that actually from the nature of turning points, from the second derivative, when it is greater than 0 like this, it's a minimum turning point. When it is less than 0 like this, it's a maximum turning point. Okay, so let's find first, which is going to be negative 6x plus 12 minus, this one is a 0. Okay, so using the first turning point here, x is equal to 1. So when we substitute here x is equal to 1, we are going to obtain minus 6 times 1 plus 12 like that, which is going to give us a positive 6. So as we can see, a positive 6 here simply says that this divide is greater than 0, because it's giving us a positive. So it's greater than 0, which means it's a minimum turning point. So this one gives us a minimum turning point. So therefore, TP1, which is the turning point 1, this one of 1 minus 4, it's a minimum turning point. Okay, then we move on to the second turning point, which is minus 6 into x. So for the, we substitute here in place of x here on the second derivative. This value of x, remember, it's x and y like that. So x is 3. So it's 3 plus 12, which is going to give us negative 6. And as you can see, negative 6 is less than 0. So which means here it's a maximum turning point. All right, because our second derivative is less than 0. So it's a maximum turning point. So therefore, TP2, the second turning point here, which is 3, 0, it's a maximum turning point, that one. That's the maximum turning point. That is what it means. Okay, so let us just finish so that we can just sketch at once. We need also the point of inflection, and we know that at the point of inflection, the second derivative should be equal to 0. All right. This is our second derivative already is there. Our second derivative is already there. So minus 6x plus 12 should be equal to 0. All right, which is minus 6x is equal to, transpose this, is going to be negative 12 divided by negative 6 by negative 6. So definitely x is going to be 2. All right. But this is a point of inflection. That is a point of inflection. So which means at point x is equal to 2, we have to find the value of y by just doing the same thing that we did last time to substitute into this original equation. So it's going to be minus 2 outside of the bracket. This minus is outside of the bracket like that. Plus 6 into 2 squared minus 9 into 2 like that. So that's what you're going to have, which we are going to obtain negative 2. That will be negative 2. All right, so we have a lot of information, guys, that we need now to sketch this graph. Okay, so this is what you're going to do. This is our point of inflection. All right, now we need to know the shape. Remember, it's a negative, so when it is a negative, therefore the shape is going to be like this. Okay, remember, we can have a shape like this when it is a positive, but when a negative like this. And also the other thing is that this is going to have a turning point here. So we have got a 0 here, and the other point was 3. Okay, let me take you back here. Remember here, guys, from our x-intercepts, x was 0 and 3. So these are the values that you're working with, 0 and 3. So let's say this is our 3 here. Okay, but this one, it's also a turning point, and this one where that's our y-intercept also. Okay, so let me take you to the turning points. All right, the turning points occurred at x is equal to 1. Okay, guys, I'm now having a mixed things here, a lot of them. Okay, anyways, this is it. We had a turning point at 3, 0 here, and another turning point at 1 minus 4. So let's just assume 1 minus 4 is somewhere here, and 3, 0 is here already. So remember, guys, the shape that we are supposed to have, and also that this is a turning point. So definitely this graph is supposed to be, this is a turning point, it's supposed to be something smoother, guys. It turns here, it goes to this point, then to that point. All right, yeah, something like this. I don't know where it's gonna go there, but that's how it is supposed to be like. All right, where this is our turning point at 1 minus 4, and this is another turning point that we are at. This was supposed to be a turning point, a clear turning point. This one is okay, something like that. So this is another turning point. Also, it's the x-intercept. This one is a turning point. As we can see, this is a minimum, this is a maximum, which actually corresponds that this is a minimum. As we can see, actually from the graph, this is a minimum and this is our maximum. So that's what we had. And also the point of inflection here, the point of inflection, remember, it was 2 minus 2. Yeah, 2 minus 2 here. So this is it here, 2 minus 2. So it's supposed to be just in between here. So 2 minus 2, that's our point of inflection, this one. Okay, so this is y is equivalent to minus x cubed plus 6x squared minus 9x. So that was the sketch. And guys, okay, so that's derivatives. Actually, that's what they want to test you. So they'll be testing you for some other things, so you need to understand what's happening there. Differentiate with respect to t. Take note, guys, with respect to t. So we are given all these expressions, and it's actually 5 marks to make it a 20 marks on derivative. So let's see what we had there. All right, so guys, we know that actually sec 1 cosec, we can't like work with that direct, but cosec 1 over sine is the one which gave us cosec. Okay, this is it, 1 over sine x gives us cosec x. So 1 over cosec gives us sine x. So whenever you see 1 over cosec, is going to be sine, because 1 over sine is what? It's cosec. All right, I hope you understand. So S is going to be 5 sine t. Take note, we haven't started to differentiate. I'm just rewriting. Okay, so this part, okay, in fact, let me just differentiate. This part here is going to give us 5 sine t. If we rewrite, then now what is going to be our ds dt from this 5 sine t? So remember, the derivative of sine, guys, is cos. So it's going to be 5 cos t. All right. Then we have got cosec t. Remember the derivative of cosec, guys. Cosec, it's minus cosec cot. Okay, let me take you here. Cosec here. Cosec x minus cosec cot. So it's minus, but there was already a minus which is there. So it's going to be plus cosec t cot t again. Cot t. Everything over 5 which is there, so there's a 5 there. Okay, plus t, the derivative of t, guys, this one is a constant, so the derivative of a linear variable, this is a linear variable which is going to give us a 1. Remember, I use that. And this is cot theta, but this is with respect to t, and here we do not have t, so it's going to give us a 0 there. Okay, then we've got 7 pi t squared, which is, remember, you drop the exponent, so it's going to be 7 pi times 2, which is 14 pi. So it's going to be 14 pi t. Remember, you drop the exponent, then you subtract 1, so it's going to be 14 pi t, like that. So that's what we needed, guys, to find the derivative of each. You are finding the derivative of each and every part. You find this part, you find this part, you find this part separately. That's the derivative for you. Okay, just like that. Just like that, guys. You know that you'll be somewhere there. So the last question, which is actually on question number 5 now, was on complex numbers and Cramer's rule, those Cramers and so forth. So the first part is to solve. And someone will ask, how am I going to solve such type of an equation? All right, let me put it here like this. This is what we had, guys. Whenever you're given such type of a question, these two lines, I told you that they represent determinants. Okay, these two lines represent determinant, where we know that the determinant of a 2 by 2 matrix, if this is A, B, C, D like this, is going to be AD minus BC. So that's the determinant. So this is our A, our D. So we're going to multiply these two together. 3 minus J2, that's A times D, which is 1 plus J3 minus this part here, which is 1 minus J3 into 1 plus J. Whatever that we get, we are going to equate to M plus JP. Remember, it's an equation, so you have to write is equal to. All right. Remember, you're now back to your complex number, so you need to expand brackets and so forth. So it's 3 and 1, which is 3, 3 and 3 here, which is 9. So it's J9, J2 and 1, which is minus J2, minus and a plus, which is actually a minus. So it's going to be J squared 2 times 3, which is 6. So it's J squared 6, which is actually a positive if you see it properly. Okay, minus is going to expand, so you have to open bracket. It's 1 and 1, which is 1, 1 and J, which is J, minus J3 and 1, which is minus J3 or 3J. I don't know how you're going to write it. Then it's minus 1 and plus 1, which is minus J and J, which is J squared 3, all right, which is equal to M plus JP. Just write like that, guys. Okay, so this is what is going to happen here. We are going to remember, we know that J squared is equivalent to minus 1. So here is going to be a negative 1 here, which is negative, and negative, which is a plus. Okay, so it's now a plus this time. So it's 3 plus 6, which is 9. J9 minus J2, which is 9 minus 2, which is 7. So it's plus J7. All right, minus, we do the same here. It's going to be minus J. Then this is J squared, which is minus 1. So it's minus and minus, which is a plus. So it's 1 plus 3. which is now 4, because this j squared gives us -1. Okay, and here you've got 1j minus j3, which is just like j1 minus j3, which is 1 minus 3, which is 2. So it's going to be j2 minus j2. Actually, 1 minus 3, guys, is -2. So it's going to be minus j2. But there's this minus, which is supposed to expand whatever that you're going to get after simplifying, which is m plus jp there. So let's just expand the brackets and collect like terms. 9 plus j7 minus 4 minus and minus, which is a plus, so it's going to be plus j2, which is m plus jp. So collect like terms. 9 minus 4, which is 5, plus j7 and j2, which is j9, which is equivalent m plus jp. So this, at this stage, as long this is understood that this means determinant and these two are equal, as long that part alone is understood, it is going to make you to know that m, which is a real term, is equivalent to the real term. So therefore m is equivalent to 5. P is equivalent to the imaginary term, the one which is affected by j, which is 9. So therefore and P is equivalent to 9. So that's it. So sometimes they can ask you to solve like this, or sometimes they can ask you to say, show that m is equal to 9, m is equal to 5, and p is equal to 9. So depends with the question that you'll be given, but there, that's what we actually needed. And what you're supposed to do depends, like I said, with the type of question that you'll be given and so forth. Then the other part is to simplify, and actually those are when you're given polar form. Remember polar form, guys. So I'm just gonna write this in a simplified manner. I'm not going to like make much here. I'm just going to write in a simplified manner actually here. All right, so this is the idea that is going to happen here. Remember in complex numbers, when we are given a polar form of r cis theta to the exponent of n, it's going to give us r to the exponent of n cis n theta, which is the same as r angle of theta to the exponent of n. Is just one and the same thing, which is polar form. So here what you're supposed to know is that this is one in the same format. So you're just going to pick one, either this one or that one. Okay, and also you're supposed to know that if I am given r, remember r cos theta, guys, r cos theta like this, plus rj sine theta was taken from r angle of theta. This is what gave us r plus. Okay, so now here we are given this concept now, 2 cis 30 to the exponent of 2. So as you can see, you're going to apply this concept of raising to the exponent, then multiplying by the exponent. So it's 2 to the exponent of 2, which, or you can just start maybe by writing the same format. I don't know what is best. 2 to the exponent of 2 is 4. So it's going to be 4 cis theta, which is, you multiply that by 2. So it's 2 times 30 here, which is 60 degrees. All right, times here there is a minus. So when it is a minus, it means it was taken from one angle of minus 30 degrees, which is 60 degrees, like r angle of theta like this, or r cis theta. But if it is a negative, it's going to be minus here. So it's going to be minus here. So this one is same as one angle of minus 60, or 1 cis minus 6. So since I have written it, this one in terms of cis, I'm going to maintain cis. But remember, there's a 3 here. So there's a 3 which is outside. So it's going to be 3 times 1, which is actually 3. Then everything is going to be raised to the exponent of 3. Take note, there's an exponent of 3. So it's now 3 to the exponent of 3, which is 27 cis. This one is going to multiply. Remember the concept, guys. You raise to the exponent, then here you multiply. Raise to the exponent, then these two multiplies. So it's 3 times minus 60, which is minus 180 degrees. All right, we are done on this part. We move on to the denominator there, we've got the same thing, 2 to the exponent of 3, which is 8. So I'm just going to write as 6, so that we don't confuse. Like I said, this is one in the same format. It can be like this or it can be like this, but as you can see, it's one in the same thing. You raise to the exponent, you multiply by the exponent. So you're going to raise, then you multiply by the exponent. 3 times 10, which is 30 degrees. Okay, so also this one in terms of 6, 3 to the exponent of 2, which is 9. 6 40 times 2, which is 80 degrees in terms of 6, times 3, 6, 50 degrees. There's nothing that we are going to do there. All right, so this is it now. Yes, we have simplified, we have applied our DMOV's theorem, where we raise to the exponent and we multiply by the exponent. Then what follows next? Okay, this is it. We are multiplying, so we are going to multiply the numbers together. Remember, in polar form, if you are multiplying, you multiply the numbers together, then the angles, you add them. All right, so we are going to multiply these numbers together, which is 4 times 27, that's 108. 6, you add the angles, so the angles you add, which is going to be 60 plus minus 180. All right, so 60 plus minus 180, which is minus 120. Is that so, guys? Which is minus 120 degrees over. You do the same here. These numbers multiply. 8 times 3 times 8 times 9 times 3, which is 216. So it's going to be 216. 6, you do the same. We add this angle, so it's going to be 30 degrees plus 80 degrees plus 50 degrees. You add all these angles together, okay, which is going to give us 160 degrees. All right, so now we are dividing. We are no longer multiplying, we are dividing. So we are going to divide the numbers together this time. The angles we subtract. So if we divide the numbers together, it's going to be 1 over 2 or 0.5. 6, here we subtract, so it's actually 6, negative 120, negative 160, like that. So it's going to be 6, negative 280 degrees. All right, so that's what you're going to have there. Like I said, depending on the format that you'll be using, if you used another format, which means your answer is going to be half angle of minus 280, like this, you put it this way, depends with the format, or you use this cis thing. It's just one and the same thing. There's nothing that is actually new there. It's just one and the same thing. Then we have on 5.3 where we need to evaluate 3 minus j, then 2. Okay, it's fine. Okay, anyways, doesn't make sense, but I don't know, maybe it's gonna make sense. Actually, I don't want to confuse this. Okay, so this is there, and according to this, actually we are given. So what can we actually do? Because here the question is just evaluate, just like that. Okay, so we have to rationalize the denominators here, where we have to make sure that the denominator is now having a real term. Also, you have to multiply both the numerator and denominator by the complex conjugate, which is the conjugate of 2 plus j is 2 minus j. So 2 minus j both sides, which means we're going to multiply 3 minus j2 into 2 minus j, like this. Everything over 2 plus j into 2 minus j, just like that. So you gotta expand brackets and something like that. Collect like terms wherever it's possible. Simplify further. That's complex numbers for you guys. So it's 3 and 2, which is 6, 3 and minus, this is same as minus 1j, so it's going to be minus j3, then minus j2 times 2, which is going to be minus j4. Okay, so this is minus and minus, which is going to be a plus. So j times j, which is j squared, 2 times 1, which is 2 actually, everything over Okay, so here we can apply the longer way, or you can just use this concept that's going to be 2 squared plus 1, which is what, 5. Or you can apply the longer way, 2 times 2, it's 4. 2 times minus j2, which is minus j2. J times 2, which is j2, plus and minus, which is minus j squared, like that. Okay, so we know that, guys, I talked about this previously, that j squared is going to give us a minus 1 here. So this is minus 1 times 2, which is minus 2. So it's 6 minus 2, which is 4. Okay, so 6 minus 2, that's going to be 4. Minus j3 minus j4, so it's minus 3 minus 4, which is minus j7, over this here will cancel. This is minus j2 plus j2, these are the same, so they will cancel, and we've got j squared, which is minus 1, but there's a minus, so it's going to be minus minus 1, like this, which is a positive. So it's going to be 4 plus 1, which is 5, just like what I said before. So it's going to be 4 over 5 minus j7 over 5, just like that. Or you can write it as a decimal, depending with what you want. As a decimal, it's going to be 0.8 minus j1,2, yeah, something like that, if I'm not mistaken there. So that is what you actually needed. So as you can see, guys, some of these questions is just a matter of application of what you'll be given at that moment. Then let us just quickly rush through this question. As you can see, now it's time, people are waking up now, and the noise is starting. Okay, we are given there to use Cramer's rule to determine the value of z only. Yeah, we need the value of z only here, not any other values, but the value of z. So guys, let us just quickly finish up this part and see what you're going to have. So this is what we have. Remember, from our Cramer's rule, the value of z is going to be the determinant with respect to z over the determinant of what? Of constants. So we are going to find determinant with respect to z, which is in place of z here. We are going to substitute with constants, which is 2, 4, and 6. So this whole part remains as it is. Remember, guys, remains as it is, which is 3, 2, and this is a 1 here. So this is 1, and this is -4, -3, -6. Okay, this in place of z, now you substitute with 2, 4, -7, just like that. Okay, so remember, guys, determinant, I told you that you pick any row or any column of your choice. So in this case, I'm gonna work with this first row here, which is plus, minus, and plus. Remember, it's plus, minus, plus, plus, and so on. So here the first row is just plus, minus, and plus, but it's supposed to be plus and minus, plus, minus, plus, plus, minus, plus, and minus, and plus, just like that. So it's plus, minus, just it's a pattern like that. Okay, so you just need to know that in this something, nothing there. All right, so this is what we're going to have. We're going to take the take here, which is 3, then the determinant of. So we are going to close this row and this column, which means we are going to be left with -3, -6, 4, and -7. Remember, guys, close the row and the column. So this row here and this column, like this, is what you're going to be left with: -3, -6, 4, and -7. Okay, so this is minus and minus, which is going to be a plus. So it's +4. Okay, this one is a plus, so that's why I didn't write, or you can just write +3. Okay, so this one is minus and minus, which is a plus, so it's +4. You close this row and this column, which means you're going to be left with 2, 1, 4, and -7, plus here 2. Close the row and the column, which means you're going to be left with 2, -3, 1, -6. So remember, guys, how you calculate the determinant: the major diagonal here minus the minor diagonal here. So it's going to be 3 into -3 times 7, whatever you get. So it's like this, -3 times -7, that's your major diagonal, minus 4 times -6, 4 times -6. Okay, so this part alone is going to give us 21 there. So it's 21 plus 4 into, you do the same, your major diagonal, which is 2, and minus 7. That's AD minus BC. So it's 2 times minus 7, 2 times minus 7, minus 4 times 1, which is this one left, 4 times 1, which is going to give us negative 8 plus guys, where am I getting this? This here gave us 45 here, so it's 3 times 45, and this is negative 18. All right, plus 2 here into this is negative 6, negative 12 minus 3, so it's negative 12 minus 3, which is plus, so it's going to be negative 9. All right, so you combine everything and that's gonna be 45. Yeah, so now it can make sense. So that's what you're going to have there, which is 45 there for the determinant with respect to z. Then we move on to constant. So you just do the same thing just like what we did. So as we can see, it's more of a repetition. So for constants, you just take as this part as it is without substituting anything. So it's 3 2 1, 3 2 1, negative 4, negative 3, negative 6, negative 4, negative 3, negative 6, and here is going to be 1 2 3, 1 2 minus 3. Remember the number and its sign. You take the number and its sign. So I'm just going to apply the same thing. Use the first row here with plus minus plus, so it's not going to be changed here. So as you can see, guys, it's now a repetition, so it's plus and 3, which is plus 3, determinant of, you close the row and the column, so you're going to be left with the minus 3, minus 6, 2, and minus 3 if you close this row and this column, guys. Okay, so it's not mistaken here. So it's minus and minus, which is a plus, so it's plus 4, determinant of, you close the row is already closed, so what you just need is to close the column. So it's 2 2 1 minus 3, 2 2 1 minus 3, plus 1 here. So the row is already closed. What you just need is to close the column with 1. So you're going to be left with 2 1 minus 3 minus 6, just like that. So guys, you do the same thing of finding the determinant. So it's 3 major diagonal minus 3 and minus 3, which is going to give us 21 minus 12 minus 12, which is, this is the one, which is going to be 21 here, plus 4 into, you do the same here, minus 3 times 2, which is minus 6, minus 2, which is minus 8, plus 1 into 2 and minus 6 here, so it's minus 12 minus 3, which is minus 9, like that. All right, so you add everything, which is going to give you 22. So this is actually the determinant with respect to constants, and we said z is equivalent to determinant with respect to z over determinant of constants. So it's just a matter of substitution because the formula is already there. We wrote the formula here, and our determinant with respect to z here we obtained 45 there, and the determinant with respect to constants we obtained 22, and as a decimal is going to be 2,0454 and so forth, which is 045, because that 4 cannot change the 5 which follows there, so that will be the value of z. So I don't know, guys, any other alternative thinking that you have. Let's see it so that we can actually work on it together and see how we're supposed to answer these typical questions. Okay, then the other part there is on 5.5, where we're actually given to solve for m. Previously in the exams which are written in Feb, it was there, this type of a question. Now they are bringing again this type of a question. Actually, there's something that you're supposed to learn about these guys there. As you can see, they are now repeating this type of a question again. All right, so already we are given the determinant that is equal to 0, so we are going to determine our determinant. So I'm just going to use the first row. As for me, guys, I love using this, unless you are told to use another, but just use that one because you are not told to use any row or any column. So you just pick any row of any column of your choice. You're going to obtain the same answer. Okay, so it's plus minus plus, which is a 2 here, plus 2, we close the row is already closed, so we just close this column here. So as you can see, you'll be left with m minus 1 minus 4 6. Okay, minus and minus, which is a plus, so it's going to be plus 1. Determinant of already the row is closed, so you're just going to close this column here, which is you'll be left with 1 minus 1 6 and 6. Okay, plus 1 over 2 here. You close the row and the column, so if you close this column, you'll be left with this part here, which is 1m 6 minus 4. So this is a representation for the determinant, and we are given that determinant, when you are solving it this way, it is equivalent to what? To a 0 there. We are given the answer. So it's a matter of solving the equation now, where we're going to have 2 into, we multiply, remember, is the major diagonal here, which is m times 6, which is 6m minus, remember, it's minus 1 times minus 4. So minus 1 times minus 4 is 4. So it's going to be minus 4. Okay, plus 1 into 6. So this one is going to be 1 times 6, which is 6 minus 6 times minus 1, which is minus 6. So it's minus minus, which is a 12 there. So this is going to give us a positive 12. All right, plus into, we do the same here. It's going to be 1 times negative 4, which is negative 4, minus m times 6, which is 6m, which is going to give us a 0 like that. Okay, so let's just expand brackets, guys, and see. That's 12m. Okay, 2 times, which is negative 8, plus 1 times this, which is 12. Half of 4, guys, from your calculator, this is negative 2. Plus and minus, that's a negative, and this is 2, and this is negative 3m, equal to 0 like that. All right, so it's now just a normal equation where we have to collect like terms. 12 minus 3, which is 9m, minus 8 plus 12 minus 2, which is actually going to give us 2. That's plus 2 there, which is going to give us a 0. Then 9m is equal to minus 2. Transpose, divide by 9. So definitely m will be equal to minus 2 over 9, which is what they needed there. So guys, as we can see, that's everything that we had. So we can actually have a total of 100 there. So I don't know, but actually that's what we had. So let's see, guys, on the comment section, what do you think about the paper? How did you see it from the revisions that you had, and what you got here? What can you say? What do you see? Do we have a hope that we actually made it, or we have to revise again for the time to come again? As we can see, actually, as on my side, just analyzing these papers and so forth, you are now seeing that there are some applications that they now need you to understand in depth, not just to know, just to say there's a topic like this. You are now supposed to understand the topic. That is how they are asking these questions. As you can see, that is how now they are asking these questions. So you need to know, you must have an inner understanding of the topic that you are working with, because as you can see, these questions actually, they need an application of mindset that according to the topic that you'll be given. So that's what we had, guys, from this question paper, which is the one that we just had. So if there is anything or any questions, guys, that you felt like they are not properly done, let me know, so that we can actually work on them. But for the meantime, let us not forget, guys, to share our videos and also to subscribe. So that's it, guys, till we meet again.